Hi guys, I'm so sorry that I'm not there today. Hopefully you've picked up the 3 things on the front table, and on our assignment sheet I actually have a typo. The numbers are all off and I had already copied it. This is day 2, this is day 3, and this is Thursday, November 3rd. So if you can make those changes, and then everything should line up, and that's the assignment sheet that we'll go off of. So right now, if you take out your note packet, and please follow along at your desk as I go through this. And what we're doing is what's called inverse trig functions. And we have to first remember what it means for something to be an inverse. We have to think back to Algebra 2. Do you remember back in Algebra 2 when you were told to find the inverse? And what we did was we could switch x and y. And so if I'm looking at this problem and I'm trying to find the inverse, this f of x I can think of as y equals 3x minus 4. So if I switch x and y, this is going to be x equals 3y minus 4. And then you're going to solve for y. So we're going to do x plus 4 equals 3y. Go ahead and divide all your terms by 3. And I get 1/3 x plus 4/3 is equal to y. That's my inverse. Another notation that you might see instead of y equals might look like this. F to the negative 1 of x. That just means the inverse of f. So it might look like this, and it's still equal to 1/3 x plus 4/3. So there's our inverse. In problem number 2, what it would like for us to do is graph f of x, and then graph its inverse on the same set of axes over here on the right. So we have to remember how to graph. Hopefully we remember a little bit. When you're graphing, this is in mx plus b. Y equals mx plus b. So my b, or my y-intercept, is negative 4. So I'm going to start down 4. And then my slope is 3. So that means from here, I'm going to go up 1, 2, 3 over 1. And keep doing that. Up 1, 2, 3 over 1. And then you're just going to connect it up into a straight line. Oops. Okay, then we're going to do the same thing for this inverse. This time our y-intercept is 4/3, which is a little bit bigger than 1, so about right here. And then my slope is positive 1/3. So I'm going to go up 1 over 1, 2, 3. And I'm going to go up 1 over 1, 2, 3. Or I could go down 1 over 3. And just do your best to draw this line in. There we go. And then if you look at these two inverses, something you may or may not remember from Algebra 2 last year is when you graph inverses, what are they always symmetric with respect to? Are they symmetric with respect to the y-axis? No. The x-axis? No. What about this diagonal line? Are they symmetric with respect to that? If I draw a diagonal line right through here, my inverses are symmetric. And what that is they are symmetric with respect to that diagonal line, which is y equals x. Okay, so that was a little bit of a review of inverses of functions. We did that last year in Algebra 2. We're not going to do number 3 right now. We're going to skip down to trig inverses, which is really what the lesson of today is about. So problem 1 here says, find the inverse of y equals the sine of x. So I'm going to switch places. So I'm going to start off by saying x equals the sine of y. So we just switch x and y. And then we have to solve for y, which gets a little bit tricky because you cannot, I hope none of you are saying, oh, just divide both sides by sine. We can't do that. Sine has to be next to something. Do we agree that y is an angle? And the reason that y is an angle is because it's next to the word sine. We only take the sine of angles. So y is an angle. How we write this is like this. Y equals, because we have to solve for y. And we put sine to the -1 of x. That's how we write the inverse. And y is always going to be an angle when we find these inverses. So if you ever see something that looks like sine to the -1, your answer is always going to be an angle. Here's how some of the other ones might look. Over here where it says inverse notation. It could be sine to the -1 of x. It could be cosine to the -1 of x. And tan. We also deal with the other ones, but these are our three main trig terms. Another way we could write it is like this. Arc sine x and arc cosine x and arc tan x. I know that that looks funny, but whether you see inverse tan or arc tan, they mean the same thing. Your answer to these type of problems will always be an angle. And our job of today is to find the angle. So let's hear some problems. It says, evaluate the following over the interval 0 to 2 pi. All answers should be in radians. So when I look at this problem right here, it says y equals inverse sine √2/2. What I'm thinking in my head is this. First of all, remember, this is going to be an angle. So my answer is going to be an angle. I'm thinking the sine of what angle equals √2/2. Okay, my answer is going to be an angle. This is going to be an angle. And then I have to think, okay, I can go between 0 and 2 pi. So I'm going to think all four quadrants. All students take calculus. And here I note that the sine was a positive √2/2. So we think, okay, what quadrants is the sine positive in? 1 and 2. I'm going to have two answers. I need to have a reference angle chart nearby. Here's a reference angle chart. And let's find our reference angle. So if I'm trying to do sine and √2/2, sine √2/2, my reference angle is pi over 4. Okay, so my reference is pi over 4. But what are my two answers? My two answers are y equals, in the first quadrant, pi over 4. And over here in the second quadrant, remember, flat down is 4 pi over 4. So my answer is 3 pi over 4 back in the second quadrant. Okay, let's try this next one. We're going to think to ourselves, not sine. We're going to think the cosine of y equals √3/2. And I'm going to try to figure out what quadrants we're in. All students take calculus. Okay, what quadrants is the cosine positive? Hopefully you said 1 and 4. Let's find our reference angle. We're going to look at our chart. We're going to look at cosine. We're going to look at √3/2. And my reference angle is pi over 6. So my reference is pi over 6. My answer to the problem in the first quadrant, pi over 6. Down in this fourth quadrant, remember that a full circle is 2 pi or 12 over 6. So back here in the fourth quadrant, it would be 11 pi over 6. And those are your two answers. Okay, let's try part C. We're thinking to ourselves, the sine of what angle equals -1/2? Okay, this time I have to think about what quadrants the sine is negative in. And the sine is negative in 3 and 4. Look at your chart. Find your reference angle. Hopefully you're getting pi over 6. Pi over 6 is not one of my final answers, though. Around to here is 6 pi over 6. So in this third quadrant, I get 7 pi over 6. A full circle is 12 pi over 6. So here in the fourth quadrant, I get 11 pi over 6. Okay, part D is a little bit unique because we start off the same way. We say, okay, the tangent of y equals 0. But we're not in a quadrant. Like if I said, where's the tangent 0? It's not in a quadrant. The quadrants are either positive or negative. And so I could look at my chart and say, oh, tangent 0, one of my answers is 0 pi, but I might have more answers. And what you have to think of for tangent, since we know that tangent is sine over cosine, whenever a problem says the tangent of y equals 0, it's the same as saying the sine of y equals 0. The reason that I can just get rid of the denominator is because if I have a fraction equals 0, it's like I'm multiplying both sides by your denominator. Okay. And so if sine of y equals 0, it's not in a quadrant. Remember, all of the points along the unit circle are cosine, comma, sine. And so I want to know where the y coordinate is 0. Well, right there and right there. And if I want to know what angles go with there, this is an angle of 0, which I can just call 0 or I can call 0 pi. Around to here is 1 pi. And if I did a full loop, 2 pi. And before I box these answers, I'm going to check the directions. And the directions said my answers have to be between 0 and 2 pi. And the bracket means I can include 0 and 2 pi if they're answers. So I'm going to include all of those. Okay, key point from this page is that the answer to an inverse trig is always an angle. Notice that all of our answers here were angles. Our answers are always angles. Okay, flip to the next page, please. And we're going to take a peek and see what the graph of these things look like. We're going to graph inverse sine, cosine, and tangent. I have our sine graph graphed for us here, and I'm just going to come on here and plot some points. This is 0, 0. Remember, out to here was 2 pi, here was pi. So right here would be the point pi over 2, comma 1. If I went in the negative direction, this would be negative pi over 2, negative 1. This point right here would be pi, comma 0. If I went in the negative direction, this point right here would be negative pi, comma 0. And all these are points on y equals sine x. If I wanted to look at the domain and the range, the domain for sine is negative infinity to infinity. It goes on and on forever. The range for sine is how high and how low it goes, so negative 1 to 1. Now think about what we might do if we were trying to graph arc sine, which is inverse sine. Remember, you take your point and you switch x and y. So we're going to take all these points and we're going to switch x and y. So let's come over to this graph first, wrap our mind around this. This time, if you look here, all of your y values go from negative 1 up to positive 1. So that means that my x values are going to go from negative 1 to positive 1. If I look over here, all of my old x values go from negative pi to positive pi. So this time I'm going to make my y values do that. Negative pi over 2, negative pi, pi over 2, pi. And then I'm just going to go point by point. I'm going to switch x and y and plot it. Okay, here. My new point is going to be 0, comma, negative pi, down here. My new point is going to be negative 1, negative 1/2. It'll be down here. Or negative pi over 2. It'll be down here. Okay, 0, 0 is easy. Stay 0, 0. Okay, my next one is going to be over 1 up pi over 2. It'll be right here. So I'm just switching x and y. And then my last one will be, that I'm going to plot, is going to be 0, comma pi. So 0, comma pi is here. Now if I connect the dots, it looks like a sideways, or it looks like my sine graph has just been shifted or rotated, and it goes up and down now. If I look at that graph and I said, what's your domain? We'd say negative 1 to 1. And that kind of makes sense, because for inverses, your domain of one and your range of the other should be the same. The issue is, this is not a function. Remember that vertical line test? If you draw a vertical line, this would not pass the test. And so what has to happen is, we have to restrict this. We have to say, what if we only used that portion? If we only used that portion, it would pass the vertical line test every time. And so the range is actually going to be, we're going to chop it off. We're going to say it's from negative pi over 2 up to positive pi over 2. So negative pi over 2, positive pi over 2. Okay. Let's try cosine. I'm going to go a little bit quicker when I graph my cosine. If you have to slow down the video, that's fine. I'm going to put my points on here. This is 0, comma 1. This is pi over 2, comma 0. Pi, comma negative 1. Negative pi over 2, comma 0. Negative pi, negative 1. Okay, I'm just going to switch. Well, I'm going to first label my x-axis. My x-axis will go from negative 1 up to 1. And my y-axis will now go from negative pi up to positive pi. And I'm just going to go each point, and I'm going to switch them. So my first point is going to be negative 1, negative pi, down here. My next point is going to be 0, negative pi over 2. 1, comma 0. 0, comma pi over 2. Negative 1, comma pi. If I connect up, it looks like this, which is not a function. Because again, if I draw a vertical line, it's not going to pass the vertical line test. So we're going to restrict it, and we're going to restrict it to right here. And so if I were to set up my domain and range, let's do the regular cosine first. My domain is negative infinity to infinity. My range is negative 1 to 1 for cosine. Now, if I'm looking at the domain of arc cosine, the domain are your x values, negative 1 to positive 1. So my domain is going to be negative 1 to positive 1. But my range is going to be a little bit different. We have to chop off our range. Our range are our y values. Y values are going to go from 0 to pi. And our last one is inverse tan. Inverse tan has, if you recall, it has these vertical asymptotes. Oops, here and here, which are happening at pi over 2 and negative pi over 2. So if I wanted to graph the inverse, it would have horizontal asymptotes at pi over 2 and negative pi over 2. It's going to look like this. And then I'm going to take this point right here in the middle, 0, 0. And if I flip it, it stays 0, 0. If I had this point right here, it would be pi over 4, comma 1. So I'm going to come over to pi over 4, and I'm going to go up 1. Okay, right in here. I'm sorry, I'm going to go up to, I said that wrong. I'm going to go up to pi over 4, and I'm going to go over 1. Okay, it's going to look like this. I'm going to have the same thing in the negative direction. It's going to look like this. And most importantly is going to be our range. Our range here is going to go from lowest to highest, negative pi over 2 up to positive pi over 2. Okay, so what does all that mean? All those graphs help us find what's called a principal value. A principal value means when I ask you from now on, from this moment on, when I say what is arc sine or arc tangent, we have to be stuck in that range that we just defined. And so for arc sine and for arc tangent, our range that we're going to be stuck between is negative pi over 2 to positive pi over 2. Tangent does not include it, but negative pi over 2 to positive pi over 2. What does that look like on the axis? Remember, our answers are angles. Here's negative pi over 2. Here's positive pi over 2. It's going to look like this in those two quadrants. Arc cosine, our range from up top, is 0 to pi. So what does that look like? Here's 0. Here's pi. Our answer is going to be in one of those two quadrants. And with principal values, you can only have one answer. Your answer is going to be an angle, but you can only have one answer. Okay. So here's what the problems are going to look like. Arc sine negative 1/2. Okay, every time we see that, this needs to be our thought process. And then these are going to start to go pretty quickly, I hope. Okay, arc sine. We are stuck between quadrant 1 and quadrant 4. Most importantly, we're stuck between negative pi over 2 and positive pi over 2. That's our restriction. Which of these quadrants is the sign negative in? And the answer to that is quadrant 4. So my answer is going to be an angle, and it's going to be in quadrant 4. You need to have your reference angle chart. So I got a mini one right here. There's our reference angle chart. And my reference angle is pi over 6, right from the chart. My answer is not pi over 6, because that's in the first quadrant. Some of you might be thinking, oh, I know, 11 pi over 6. But it's not 11 pi over 6. If you are in quadrant 4, your angle must be negative to fit in the restriction from negative 90 to positive 90 degrees, if we think of it in degrees. So my answer is negative pi over 6. Let's try this next one. Inverse cosine. As soon as we see inverse cosine, we say, okay, we're restricted from 0 to pi. Which of those two quadrants is the cosine negative in? And of those two quadrants, the cosine is negative in quadrant 2. Look at your chart. Your reference angle is pi over 3. The angle in the second quadrant, think of this as 3 pi over 3, is 2 pi over 3. Okay, your answer is always an angle. Let's try this next one. Arc cosine. Quadrant 1 and 2, that's where we're restricted to. We say, okay, this is positive root 2 over 2. Which of these two quadrants is the cosine positive in? Quadrant 1. My reference angle, look at your chart, pi over 4. And in quadrant 1, my answer is just pi over 4. Okay. Arctan negative 1. Okay, so I see arctan. We're restricted to quadrants 1 and 4. And we say, okay, which quadrant is the tangent negative in of those two? It's going to be in quadrant 4. Look at your chart. Your reference angle from your chart, tangent, and 1, it's pi over 4. So my reference angle is pi over 4. Think about how do we list any angle in quadrant 4? In quadrant 4, we're going to say our answer is negative pi over 4. Again, the reason that we do that, because your answer has to be between negative pi over 2 and positive pi over 2. Okay, let's try the next one. Arc sine. quadrant 1 and 4. It's negative. We're going to pick quadrant 4. Look at your chart. My reference angle is pi over 3. Because I'm in the 4th quadrant, my answer is going to be negative pi over 3. Try number 6. Arc sine, quadrant 1 and 4. It's negative, quadrant 4. My reference angle is pi over 4. My answer, because I'm in the 4th quadrant, is what? Negative pi over 4. Okay. These last 6 on here are kind of special cases. Excuse me. So, start off the same way. Inverse sine. But whenever it is inverse sine or cosine of negative 1, 1, or 0. So pretty much all these cases, all of them, are special cases. And what's happening is your answer is still going to be an angle, but your answer is on the axis. It's not in a quadrant. And so I want to know, where is the sine negative 1? Well, down here, this point is 0, negative 1. Remember, all of our points are cosine comma sine. So right down here, the sine is negative 1. The angle that is down there, because I rotated down, is negative pi over 2. Let's try number 8. Okay, inverse cosine. Okay, it's a special case, so it's going to be one of these 3 spots on the axis. I want to know, where's the x-coordinate, negative 1, and it's right here. The x-coordinate's negative 1 over there. The angle that's over there is pi. So pi is my answer. Our answer is always an angle. Okay, number 9. Arc sine. So here and here. This is a special case. Sine is my y-coordinate. I want to know, where's the y-coordinate, positive 1. And it's straight up in the air. And the angle that's straight up in the air is pi over 2. Okay. Push pause and see if you can do 10, 11, and 12. Okay, hopefully you got 0 pi, pi over 2, and 0 pi. Your answer is always an angle. Okay, if you got stuck, watch. If not, you can fast forward. Cosine is here or here. This is where my x-coordinate is 1. Cosine, oh, I messed that up, I'm sorry. Cosine is not there or there. Cosine is first and second, but where is the x-coordinate 1? Right here. Cosine's here. Where's the x-coordinate 0? Right there. And sine is quadrant 1 and 4. Where's the y-coordinate 0? Right there. Okay, take a moment, pause the video again, and I would like for you to practice all of the problems here at the bottom of the page. Please press pause, unpause when you are finished. Okay, take a moment to check your answers. Okay, and we still have one more page, so go ahead and flip over. And I kind of like these guys a little bit better. Well, you'll see. These ones are composite inverse functions. So it's an inverse function inside of another function. But hopefully you like them. Always work from the inside out. So on the inside, it says arc cosine. The answer to any arc is an angle. Do we know from our chart the cosine of some angle is 3/4. No, 3/4 is not on the chart. So if it's not on the chart, what we have to do is we have to draw a triangle. We're good at that. Let's draw our XY axis. Think about cosine. Arc cosine, I can be in quadrant 1 or 2. This is positive, so I'm going to be in quadrant 1. Okay, so let's draw our triangle in quadrant 1. Here's theta. I know that cosine is adjacent over hypotenuse. So my adjacent side is 3, my hypotenuse side is 4. That missing leg is not 5. If I did a Pythagorean theorem on that guy, it would be √7. And that's all I need from there. Okay, that's all I can do from the inside is draw a triangle. Now, on the outside, I still have secant. And the answer to this, remember, was an angle. I don't know what the angle is, so I'm going to write it as theta. And then I'm going to use the triangle to find the secant of theta, which is going to be hypotenuse over adjacent. Hypotenuse is 4, adjacent is 3. Now look at this problem. Does anybody see a shortcut? These guys right here are reciprocals of each other. Look at the answer. Are those answers just reciprocals? Yes. So this is a shortcut problem. If you recognize that two things are reciprocals, you don't have to draw a triangle and you don't have to do anything. You can just state the answer. So scan your page here and look, do you see any other ones that are reciprocals? So no. Number 3. What do you think the answer to number 3 is? Just 3/2. Don't have to show any work. And none others are reciprocals. Okay, number 2 is a nice shortcut as well. We could draw a triangle, but these guys are the same. Sine, arc, sine. If ever you realize they're the same, your answer is just going to be the same. 4/5. Kind of like cross off sine, arc, sine. Look at number 4. What do you think the answer to number 4 is? 3/8. They're the same. Okay, I'm going to skip 5, 6, 7, 8 for a moment, and I'm coming down to these last 2. Okay, these are not reciprocals, and they are not the same. So I say, okay, inside here, my answer is going to be an angle. I don't know what it is. I'm going to call it theta, and I'm going to draw a triangle. Arc, sine. I can be in 1 or 4. This is positive. We're going to be in quadrant 1. Draw your triangle. Okay, sine is opposite over hypotenuse. Do a little Pythagorean theorem off on the side to find your leg. And I get √5, and it's positive. This angle right there is theta. That's all I do with the outside. I'm sorry, that's all I do with the inside. On the outside, I still have secant, but that inside is just theta. So my problem is really just find the secant of theta. So look at your triangle. I know that secant is hypotenuse over adjacent. So 3 over √5. You're allowed to leave the radical in the denominator. Okay, let's try this one. Work on the inside. Arc, sine. Think to yourself, arc, sine. I'm stuck here and here. I'm going to be in the first quadrant. So draw your triangle, try to label all your sides. Double check your triangle, make sure it looks like mine. Make sure you have theta in there in the coming out of the origin. And then I rewrite. Tangent. This inside was an angle. I didn't know what it was, so we're just going to replace it with theta. Now look at your triangle. opposite over adjacent, my answer is 4/3. Okay. Okay, now I did skip over 4 here in the middle, so we need to go back. Problem number 5. The reason that I skipped over it is because inside here, my answer is going to be an angle. But we can actually figure out what that angle is because that's on the chart. So on the inside, I don't have to draw a triangle. I can, if you like drawing the triangles, draw them, or we can just find this angle. I can think to myself, okay, inverse sine here and here. I'm actually going to be in quadrant 4 because it's negative. Look on your chart, look at sine, root 2 over 2. My reference is pi over 4. But think to yourself, we're in quadrant 4, so we have to write it like this. Negative pi over 4. Because we were in that 4th quadrant. So this time I replace this inside with an actual angle. And now I'm trying to evaluate the cosine of negative pi over 4. Okay, negative pi over 4 is down here. There's negative pi over 4. All students take calculus. If I'm evaluating the cosine down there, it's going to be positive. My reference angle is pi over 4. And look at your chart. Cosine, pi over 4. My answer is root 2 over 2. Okay, let's try this next one. Inside here, this is on the chart. This is going to be an angle. Quadrant 1 or 4. This is positive, so we're going to be in quadrant 1. Look at your chart. What angle is that inside going to be replaced with? Outside is still tan, but on the inside, it's pi over 4. And then look at your chart, and the tangent of pi over 4 is 1. Okay, last two. Inside here, arc sine -1 and arc cosine -1. Those are our special cases, which means they're not in a quadrant, they're on the axis. Let's figure out where. Arc sine can be here or here. I need to think about where the y-coordinate is -1, and it's right there. And the angle that is straight down is negative pi over 2. So I can replace that with negative pi over 2. I still have cosine. And now I'm trying to evaluate the cosine of negative pi over 2. Well, here's negative pi over 2. So I rotate down, and then cosine is just my x-coordinate. 0. Let's try the next one. Arc cosine. So inverse cosine. I'm stuck between quadrant 1 and quadrant 2. It's a special case, so I'm going to be on the axis. I want to know where the x-coordinate, because cosine is x, is -1. And it's right here. And the angle that goes around to there is pi. So I'm going to rewrite the outside as sine. And I'm going to replace that highlighted stuff with just pi. And then I have to evaluate the sine of pi. So pi is over here. Sine is my y-coordinate. My answer is going to be 0. Okay, I know that that video was long. Thank you for following along. Your homework and what you can use the rest of the class period for is to complete homework number 1 in the packet, and I will post answers. Good job.